Think of a book that mentions about a fact that science was able to discover only 100 years ago, more than 1,400 years ago. Think of a man that mentions about a fact that science was able to discover only recently, more than 1,400 years ago. Could anyone doubt that this book is a divine book, and this person is an extraordinary person? The Quran mentions more than 1,400 years ago that the universe was expanding. The following is stated in verse 47 of the chapter of Az-Zariyat. With the power and skill did we construct the firmament, for it is we who create the vastness of space. The Arabic phrase "Inna limusiyun" means we are expanding it. The word musiyun is derived from the verb eosau, to expand. The letter lam, el, at the beginning of this word is used to emphasize the noun or the adjective it precedes, and it means a lot or very much. Accordingly, this phrase means we are expanding the universe a lot. After analyzing the verse of the Quran, informing us about the expansion of the universe, we will examine what science says about it. There was only one view that prevailed regarding the issue up to the beginning of the 20th century. This view stated that the universe had a static structure and that it has existed like that since the beginning of the universe. No scientist mentioned the expansion of the universe until the 20th century, let alone mentioning. No one even imagined it. At the beginning of the 20th century, Russian physicist Alexander Friedmann and Belgian cosmologist George Lemaitre calculated theoretically that the universe was moving continuously and expanding. This fact was proven through observation in 1929. While examining the sky through a giant telescope, the American astronomer Edwin Hubble discovered that stars and galaxies continuously moved away from one another. Stars and galaxies moved away not only from us, but also from one another. In the following years, it became certain through observations that the universe was expanding. A universe in which everything continuously moves away from one another means a universe that is continuously expanding. In order to understand the expansion of the universe better, we can think as follows. Suppose that the universe is the surface of an inflated balloon. The points on the phone move away from one another. Similarly, the objects in the universe move away from one another as the universe expands. When this scientific fact was not known by anyone, and when people thought that the sun was as small as an apple, the Quran mentioned this fact centuries ago, and it stated clearly that the universe was expanding. This clearly proves that the Quran is Allah's word. That a scientific fact, which was discovered only in the 20th century, existed in a book 14 centuries ago, and that this fact was informed by a person who could not read nor write, can be possible only through one of the following two ways. 1. A human being discovered this scientific fact on his own. 2. This fact was expressed by Allah, who created the universe and is expanding it. The book in which this fact is written is the Book of Allah, and the person who conveyed this message is His messenger. There is no other alternative, and it is not possible to accept the second alternative, For it is not possible for an illiterate person living in a period 14 centuries ago, when there were no telescopes, to discover, on his own, a fact that could be discovered only through giant telescopes. Therefore, the greatest geniuses in the history of the world could not draw the model of the expanding universe despite their observations and scientific studies. They could not even imagine it. Then this information cannot be the word of an illiterate person who lived in the desert 14 centuries ago when there was no technology. The book that contains this information cannot have been written by him. Then there is only one alternative left: to accept the second option. That is, this information was given by Allah, who created the universe and is continuously expanding it, and who sent this miraculous information to people through his messenger, Hazrat Muhammad, peace be upon him. And the book that contains this information is his book. If someone said, he may have written in coincidentally, that is, the Quran is the word of a human, and this human being wrote this fact in his book without being aware of it, and mentioned the expansion of the universe, we would say, millions of books have been written since that century. If it had been possible for a human being to write this fact coincidentally in his books, the same fact would have occurred in some other books coincidentally. However, it is just the opposite. This fact was not mentioned in any of the books written by human beings, and even in the books of genius astronomers up until the 20th century. This fact was not thought about by anyone, and it was not written in any books. We cannot attribute the fact that this information was given by the Quran to coincidence. Therefore, it is impossible to say anything other than the Quran is the book of Allah. Only one alternative is possible. The Quran is the book of Allah.
How can astronomers determine distances in the far reaches of the universe? A small galaxy close in looks similar to a large galaxy farther out. This is a real challenge that researchers have found several solutions for. One method uses something called a standard candle. A standard candle is a type of object or event that emits a specific known amount of light, allowing scientists to find its distance with a straightforward formula. This works because light sources appeared predictably dimmer the farther they are from an observer. Since astronomers know how much light a standard candle gives off, they can determine its distance by measuring how dim it appears from Earth. Since only very bright objects or events are visible in the far reaches of the universe, the options for standard candles are limited. Some of the best and most reliable are exploding stars, called supernovae. There are a few different kinds of supernovae, but the best for standard candles are type 1a. These supernovae involve a white dwarf, the leftover core of a dead star, and one other star in a binary system. Some of the time, it may be a white dwarf and a larger host star. Scientists think the white dwarf steadily accumulates material shed by the host star, gaining mass in the process. When it reaches a specific tipping point, the white dwarf has gained enough mass to trigger a runaway reaction at its core, and it explodes spectacularly, sending out an expanding sphere of super-hot material that glows from the energy of the explosion. In other cases, scientists think two white dwarf stars may form the binary. Either the stars finally merging together triggers the supernova, or it happens as they spiral in closer and closer, while the more massive of the two pulls material off its companion in the final few minutes. Before they merge, it reaches the same mass tipping point and goes supernova, always releasing a similar amount of energy. Because white dwarf explosions are all so similar, the energy and light output of Type 1a supernovae are easy to standardize. Type 1a supernovae are rare in any one galaxy, occurring only once every 500 years or so in the Milky Way. But because there are so many galaxies, astronomers using current telescopes observe Type 1a supernovae about 100 times a year. By comparing the observed brightness with the intrinsic brightness, astronomers can determine their distances within 6%. The Nancy Grace Roman Space Telescope, set to launch in the mid-2020s, will observe large patches of sky repeatedly, increasing the opportunities to spot these supernovae. Scientists predict Roman will see as many supernovae in 1 month as they've found in the last 20 years. Finding more of them will help astronomers refine the accuracy of this method, contribute to an improved three-dimensional map of the universe, and better understand how the universe has expanded and evolved throughout cosmic history. The universe. For all we have learned about it, we have only just begun to reveal its secrets. What are dark matter and dark energy? How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? The Nancy Grace Roman Space Telescope will help answer these fundamental questions. Formerly known as WFIRST, the Roman Space Telescope is similar to Hubble, but with the benefit of 30 years of technological improvement. Each image from its wide-field instrument will have the depth and clarity of Hubble's best, but capture a sky area 100 times larger. The Roman Space Telescope will take the lead in exploring dark energy and dark matter. We only know they exist by their effects on observable matter, yet these two mysterious components make up 95% of the universe. The Roman Space Telescope's powerful 2.4-meter mirror and enormous field of view will also help us in the search for planets beyond our solar system, or exoplanets. It will watch for gravitational microlensing events, caused when a planet and its host star pass in front of a background star. Such events are rare, so catching them requires watching large swaths of the sky. To deepen its study of exoplanets, the Roman Space Telescope will house a beyond state-of-the-art coronagraph that will directly image and analyze Neptune-sized planets in orbits slightly larger than Earth's, a dramatic improvement over current capabilities. The Nancy Grace Roman Space Telescope will help us answer many of the biggest cosmic questions. Its wide-field view and coronagraph will complement missions like NASA's James Webb Space Telescope and Transiting Exoplanet Survey Satellite, TESS. The Roman Space Telescope will be an indispensable part of space science during the next decade and beyond.